Okay, so number 8, cannon shoots a large cannonball. The cannonball has a speed of 125 meters per second when it leaves the barrel. If the elevation is 32 degrees, what is the horizontal distance the cannonball travels? So what we're going to do is draw our picture. Cannonball traveling, and there goes the cannonball. The angle is 32 degrees. The speed as it's coming out here is 125 meters per second, and the angle is 32 degrees. And we want to find out how far downrange it goes. So we want the horizontal displacement. What you're going to have to do is resolve these into x and y components. That's the first thing that you need to do. And the horizontal is equal to the magnitude of the vector times the cosine of the angle theta. And that's equal to 125 cosine 32. And the horizontal velocity is 106 meters per second. The vertical, same thing. Y component is equal to V sine theta, and that will be 125 times the sine of 32, and it should be smaller than the horizontal velocity because of the angle, and that's going to be 66.2 meters per second. So that gives you the horizontal and vertical components. From there, we need to find out what the time is, because once we have found the vertical velocity, we can calculate the time by using 5 columns and 2 rows. So let's go ahead and draw our 5 columns and 2 rows. Make it kind of big here. 2, 3, 4. And so displacement, time, the initial vertical velocity, the final vertical velocity, and the acceleration. Time is what we're looking for. The initial vertical velocity is 66.2 meters per second up. The final vertical velocity at the top up here is going to be 0, and then the acceleration, of course, is negative 9.8 meters per second squared. Displacement is non-participatory, so then if we take this and use our equation, we see that the acceleration is equal to the final velocity minus the initial velocity divided by the time. The final velocity being 0, we can get rid of that and then solve for the time. Time is going to be equal to the negative initial velocity divided by the acceleration, and time is equal to the negative 66.2 meters per second. I'm sorry, that negative should not be there. So let me get rid of that guy and that guy there. Divided by negative 9.8 meters per second squared. And the time that it takes to go from the bottom to the top is 6.76 seconds. Where did he come from? Come on, where did he go? Come on. Oh, for crying out loud. 6.76 seconds. Now that's the time it takes to go from here to the top. What we need is the entire going across, so we need to multiply this times 2. So the total time is going to be 13.5 seconds. So that's the total time that it takes to go the entire flight. So now that we've got the whole flight time, we can now find the displacement traveled. So the horizontal velocity is equal to the horizontal displacement divided by time. Solving for the horizontal displacement, that's equal to the horizontal velocity times time, and that's equal to 106 meters per second times 13.5 seconds, and that will then give us a grand total of 1.43 times 10 to the 3 meters, and that's the horizontal displacement. Sorry to jumble that up, but that's what it is, and that's how far it would travel. All right, thank you.